Welcome to our presentation on assembly considerations for umodule R, ball grid array, and land grid array packages. Let's explore the essential guidelines and techniques for effective assembly. Welcome to our presentation on package construction for ball grid array and land grid array packages. We'll explore essential guidelines and considerations for effective printed circuit board design and assembly. Welcome to our discussion on package construction for ball grid array and land grid array packages. We'll explore the essential elements and techniques involved in constructing these advanced packaging solutions. Let's examine LGA pad finishing. Electroplating involves nickel layers of 3 to 20 micrometers. Any pig uses nickel from 3 to 8 micrometers, gold from 0.3 to 0.8 micrometers, and palladium from 0.05 to 0.1 micrometers, with an additional gold layer of 0.1 to 0.5 micrometers. Let's examine BGA pad and ball geometry. The table outlines dimensions. Pad pitch ranges from 0.65 to 1.27 millimeters, pad opening from 0.35 to 0.63 meters, solder ball diameter from 0.40 to 0.75 millimeter, and height from 0.30 to 0.60 meter. Materials used include SnagQ, SAC305, or SNPB, Eutectic. Welcome to our discussion on PCB design guidelines for BGA and LGA packages. Let's explore the essential design considerations for these packages. For umodule R BGA packages, solder mask-defined SMD pads are standard. Table 3 outlines BGA PCB pad layouts with specific pitch and pad sizes. Table 4 details LGA PCB pad layouts, including square and round pads, with variations for devices like LTM4604 and LTM4608. Ensure mixed SMD and NSMD pads maintain designed finish sizes. Welcome to our discussion on PCB design guidelines focusing on round pads for ball grid array and land grid array packages. Let's explore the essential design considerations for these components. For BGA and LGA packages, use solder mask-defined round pads. Ensure the solder mask opening is precise, as indicated by A millimeters. The copper pad, B millimeters, and pitch, P millimeters, are crucial for optimal layout. Refer to tables 3 and 4 for detailed specifications. This slide presents the recommended layout for ball grid array and land grid array mixed round pads. It includes surface mount device plane and non-solder mask defined signal pad configurations. Key dimensions are A for solder mask opening, A1 for another solder mask opening, B1 for copper pad, and P for pitch. Refer to tables 3 and 4 for detailed specifications. This slide covers the recommended non-solder mask-defined NSMD round pads with interstitial vias and thermal relief for ball grid array, BGA, and land grid array, LGA. Key parameters include solder mask opening, A1, copper pad, B1, and pitch, P. For detailed dimensions, refer to Table 3 and 4. For BGA and LGA isolator products like LTM28XX and LTM9100, ensure all I/Os or standalone pads use non-solder mask-defined NSMD pads. The copper pad, B1, should connect to the ground or power plane, with the solder mask opening, A1, properly aligned. Ensure the maximum solder mask opening for plane separation is controlled, especially for pitches of 0.8 millimeters or greater. This is crucial for maintaining the integrity and performance of ball grid array and land grid array packages on printed circuit boards. Welcome to our discussion on PCB design guidelines for square pads in LGA packages. Let's explore the essential considerations for effective design. For LGA solder mask-defined square pads, ensure the solder mask opening is dimensioned as A in millimeters. The copper pad is labeled B and the pitch is P. Refer to tables 3 and 4 for precise measurements. Let's explore the recommended SMD plane and NSMD signal pad layout for LGA mixed square pads. Key dimensions include solder mask openings A and A1, copper pad B1, and pitch P. For precise measurements, refer to tables 3 and 4. We focus on LGA solder mask-defined square pads with interstitial vias for thermal relief. Key parameters include the solder mask opening, copper pad dimensions, and pitch. For precise measurements, refer to Table 3 and 4. For LGA non-solder mask-defined square pads, ensure a minimum solder mask opening of 0.73 millimeters. The layout includes interstitial vias with thermal relief. Refer to Table 3 and 4 for precise dimensions of solder mask openings, copper pads, and pitch measurements. Welcome to our discussion on moisture sensitivity considerations for BGA and LGA packages. Let's explore the critical factors affecting these components. Module R, products adhere to moisture sensitivity level 3 or 4 standards. Track floor life, 168 hours for moisture sensitivity level 3, 72 for moisture sensitivity level 4. Analog Devices Inc. ships in bakeable trays with desiccant. Check packing integrity. If moisture indicator is pink or seal is punctured, bake at 125 degrees C for 48 hours. Vacuum seal used trays with desiccants and humidity indicator card. Welcome to the solderability test for land grid array package. Today, we'll explore the testing procedures and standards for ensuring reliable solder connections in land grid array packages. ADI Module R, BGA products do not undergo solderability tests. For LGA products, the solder dip method is unsuitable. Instead, solder paste is screened onto LGA pads, followed by reflow furnace processing, simulating the surface mount process per GDEC specification JESD22B102. Let's explore the board assembly process for ball grid array and land grid array packages. This involves precise techniques to ensure reliable connections and optimal performance. Understanding these processes is crucial for effective implementation in electronic assemblies. For BGA stencil design, stainless steel laser cut stencils are recommended. It's advisable to use a slightly smaller stencil aperture than the pad opening, particularly for surface mount device pads. Refer to Table 5 for recommended dimensions, including pad pitch, pad opening, and stencil thickness. For LGA stencil design, stainless steel laser cut stencils are recommended. Ensure a corner radius of 0.06 mm on the aperture. Refer to Table 6 for recommended stencil dimensions, including pad pitch, pad opening, stencil opening, and thickness for both square and round pads. For BGA and LGA screen printing, use low voiding solder paste, Type 3 or IV. Options include SNPB and PB-free SAC305 variants. Ensure print definition and regular cleaning to prevent stencil clogging, which can lead to poorly defined solder joints. For LGA M Module R placement, typical BGA systems are suitable. Ensure the LGA part is pressed into the solder paste for optimal pad contact. Adjust placement systems using force or Z height to prevent paste squeeze out while ensuring pad contact. Verify with X-ray before and after screen printing to ensure good solderability and minimal voiding. For optimal BGA and LGA reflow profiles, use a 9-zone oven with oxygen control. Ensure profiles include all components and thermocouples. M Module R devices can be reflowed up to 3 times. Follow solder paste vendor profiles, but never exceed peak temperatures in Table 7. All Module R devices withstand PB-free peak reflow temperatures. For ball grid array and land grid array reflow profiles, lead-free solder requires a preheat soak between 150 degrees C and 200 degrees C for 60-120 seconds, with a liquidus temperature of 217 degrees C. Leaded solder soaks between 100 degrees C and 150 degrees C, with a liquidus temperature of 183 degrees C. Both profiles recommend a ramp rate of 2.5 high degrees C, second maximum, and a peak temperature time of 8 minutes maximum. ADI IPC recommends a maximum 25% void criteria for solder joints. If voiding exceeds this, use a longer soak profile. For lead-free paste, soak at 150 degrees C to 200 degrees C for 90-120 seconds. For tin lead paste, soak at 100 degrees C to 150 degrees C for 90-120 seconds. Adjust soak time to the paste vendor's maximum if needed. For BGA and LGA cleaning, no clean paste is recommended. Water-soluble paste can also be effective with M Module R packages. It's advisable to use a saponifier and/or a deionized water spray system for optimal results. Welcome to our discussion on the second side assembly guidelines for ball grid array and land grid array packages. Let's explore the best practices for these components. Analog Devices Inc. advises evaluating LGA and BGA M Module R devices for second side reflow, considering PCB assembly equipment and process. Use component weight total pad, area A0.0465 GRMM2 as guidance. Avoid second side reflow for isolated exposed heatsink, COP devices, and M Modules R over 4 mm thick. Reworking BGA and LGA packages requires precision. Ensure proper handling to avoid damage. Follow guidelines for successful rework, maintaining device integrity and performance. Identify the failure mode on the board, checking for opens or shorts. For opens, inspect solder joint quality. For shorts, use X-ray to verify pad or stencil design. Conduct electrical tests for no output issues. Bake the printed circuit board assembly at 125 degrees Celsius for 48 hours before removing umodule R packages to prevent delamination and damage. For umodule R device removal, use a BGA and SMD rework station with top and bottom profiling. Avoid handheld heat guns. Shield sensitive components. Use thermocouples for temperature monitoring. Maintain bottom temperature between 230 degrees C and 245 degrees C. Ensure solder reaches above liquidus to prevent PCB pad damage. SNPB BGA max temperature is 220 degrees C. When placing and reflowing a new component, ensure the removed component is not reused. Follow a reflow profile with adequate soaking time and time above liquidus, as detailed in Table 8. Use thermocouples on all parallel connected modules. Inspect solder joints using X-ray for quality assurance. Let's examine a rework profile example for ADI placement. This involves ensuring precise component placement and maintaining optimal reflow conditions. Proper profiling is crucial to avoid defects and ensure reliability in umodule R devices. Let's examine umodule R device assembly and rework. A good example shows no shorts, meeting moisture sensitivity level floor life with reflow peak temperature within spec, and baking before removal. Conversely, a bad example has solder shorts due to exceeding moisture sensitivity level floor life, out of spec reflow temperature, and no pre-removal baking, leading to delamination. Today, we focus on handling BGA packages with dual components. Proper handling is crucial to ensure reliability and performance. We'll explore techniques and considerations specific to these packages, emphasizing the importance of precision and care in their management. Let's discuss the SMT nozzle and pick-and-place process for packages with dual components on top. Specifically, we'll focus on Type 1, inductor pickup, which involves a dual inductor design. This design requires precise handling to ensure accurate placement and functionality. The Type 1 inductor pickup focuses on a dual inductor design. This approach enhances the efficiency of the pick-and-place process for packages with dual components on top. It ensures precise handling and placement, crucial for maintaining the integrity of the components during assembly. Type 2 focuses on package body pickup. This method involves using a specialized nozzle to securely lift the entire package body, ensuring precise placement. It's crucial for handling components with dual elements on top, maintaining alignment and integrity during the pick-and-place process. The LTM4678 BGA is picked up using a custom nozzle. It travels to the camera vision system for precise alignment. This ensures accurate placement during the Type 2 package body pickup process. The custom nozzle is designed for BGA Type 2 package body pickup. This ensures precise handling of packages with dual components on top, optimizing the pick-and-place process. Welcome to our discussion on the maximum mechanical load for heatsink attachment. Let's explore the critical parameters for ensuring optimal performance and reliability. Ensure mechanical load is applied uniformly and perpendicular to the package top surface. Apply the load briefly, such as during heatsink attachment. Support the printed circuit board fully under the component area to prevent flexing. The maximum load should not exceed 350 pounds per square inch. Let's address some frequently asked questions. These cover stencil design, paste types, cleaning methods, inspection techniques, and usage of umodule R products on printed circuit boards. Understanding these aspects ensures effective implementation and troubleshooting in your projects. For stencil opening and thickness, refer to the stencil design page. Both no-clean and water-soluble pastes, Type 3 or IV, are suitable. Effective printed circuit board cleaning can be achieved with inline or rotary aqueous systems. Use 5DX or X-ray for solder joint inspection. umodule R products can be used on both printed circuit board sides, except as noted in guidelines. Check for solder joint shorts to prevent part shorting. To prevent shorting inside the module, check the floor life and bake parts if necessary. Ensure reflow peak temperature is within spec. After rework, bake the PCB and avoid using a heat gun. Removed umodule R devices cannot be reused. Maximum force on a module package is 120 lbs for a 15x15 mm size.